Okay, number 35, 6.4. The charcoal formed from a tree killed in the volcanic eruption that formed Crater Lake in Oregon contained 44.5% of the carbon-14 found in the living matter. About how old is Crater Lake? So we have some data here we can use. Kind of get started. We know that this is our general formula for exponential decay. So y equals y sub 0 times e to the negative k. K is positive, so negative k. T. Now we have the half-life formula that we derived in the book, and that's that the half-life equals the natural log of 2 over k. So if I multiply by k and divide by half-life, I have k equals the natural log of 2 over the half-life. We know the half-life is 5,700 degrees for the carbon. So that's the natural log of 2 over 5,700 is k. All right. Now they say the charcoal from a tree killed in the volcanic eruption contained 44.5% of the carbon found in living matter. So that means some of it had decayed. Okay? So only had 44.5% left, which is 0.445. Now if we put our k value into our general form, this is what we've got. Okay? Y equals y sub 0 e to the negative natural log of 2 over 57. There's our k. This is negative, and that's t. Now, the ratio of the carbon that we started with over what we've got, this is what we started with, this is what's left, is 44.5% or 0.445. So that's this ratio, all right, of what we started with to what we have, or what we have to what we started with. That's 44.5%. So that's going to be equal to e to the negative natural log of 2 over 5,700 t. Okay? So you have to remember that when it contains 44.5% of the carbon, that means that a little bit more than 55%, 55.5% probably went bye-bye, decayed. Okay, so we want to find out what t is, so we take the natural log of both sides. So the natural log of 0.445 equals the natural log of e, negative natural log of 2 over 5,700 t. And then we'll move that in front. So we have the natural log of 0.445 equals negative the natural log of 2 over 5,700 t times the natural log of e, but that's just 1. And then if we want to find out what t is, we divide both sides by the coefficient of t. So the natural log of 0.445 divided by negative natural log 2 divided by 5,700 equals the time. And if you work that out, you get approximately 6658, right, or 6,658 years. So it's kind of an old lake. All right. Okay, and then number 37. Again, we've got our exponential form, and number 37 says, what is the half-life of a substance that decays to 1/3 of its original radioactive amount in 5 years? So we know in 5 years, the ratio of what I have to what I had is going to be 1/3. That's going to be e to the k and 5 years. Okay, which equals 1/3, pardon me. It's going to be equal to that. And then we just want to find out what k is, so we can take the natural log of both sides. So the natural log of 1/3 equals the natural log of e to the k times 5. And we can move that in front, so the natural log of 1/3 equals 5k times the natural log of e. And then that's just going to be 1. So we'll divide both sides by 5, and we end up with a natural log of 1/3 divided by 5 equals k. So, with this relationship, we know that 1/3, that's the ratio of what we have to what we had, is 1/3. So we can divide that out, and then it allows us to use the equation to find out what k is. And now we're going to go back. Now we've got our k, so we can write a general form for this situation, this particular situation. And we'll write our general form, y equals y sub 0 e to the k. But what's k? K is this guy, the natural log of 1/3 divided by 5, or I can multiply by 1/5. It's a little bit easier to write like this. And now we want to know what the half-life is. What is the half-life of the substance? So we want to find out the t. I forgot my t, sorry about that. So we know that the ratio y over y sub 0 for the half-life is 0.5. So we divide that out, and that equals e to the 1/5, the natural log of 1/3 t. This is my half-life technique. And then again, I take the natural log of both sides. The natural log of 0.5 equals the natural log of e to the 1/5 natural log of 1/3 times t. And then again, I bring that in front, so I get the natural log of 0.5 equals 1 over 5 times the natural log of 1 over 3 t, and that's times the natural log of e, because I bring my exponent in front, but that's just going to go to 1. So again, in order to find out what t is, I have the natural log of 0.5 divided by 1/5, the natural log of 1 over 3 equals t. And when you divide that out, work that out in your calculator, you're going to get t is approximately 3.15 years. So that's the half-life. Okay, hope that makes sense. It's not too difficult. You're just kind of pinging back and forth with the data you've got. Hope that makes sense, and good luck to you.